Intel has a very unique program where they take up the different kind of innovators all across the world and created this program called Intel Software Innovator. I'll also guide you up students, like for the students, how to become student ambassador for Intel, and for the innovators across the world, you also can apply for this Intel Software Innovator program. Okay, then we'll try to keep this session, uh, let's say, in terms of let's say in terms of the use cases. So what are the different use cases which we can work with, and keeping it on a very high level so that we can take it up, let's say, step by step up. And wherever you guys face any issues, it's beyond saying, like, you guys can stop me, you guys can ask queries, right? Hi Kyle. Hi Kyle, you're a student here. Sorry if I'm pronouncing your name wrong. Hi Farwa from Pakistan, student. Okay, MPhil Zoology. Thanks for joining today. Okay, Ivani, you did have a very global presence of the different kind of students. Thanks.
Yes, the participants are from Morocco,
Okay.
from Kuwait.
Okay, nice. Hi Balvinder. Hi Christian. Okay, awesome. So interesting, pretty interesting.
It's being like that. I want the session so that the session can reach to the entire world. The people should know that what exactly we are going to cover in this current topic.
That's really awesome. Thanks for giving me the opportunity, first of all. Yeah. That's great. So Satyanarayan, student, Jaswal, student, awesome. So I see that there are a lot of students. Okay, we will. So especially for the students and who are from let's say non-AI background, or okay, let's say, what do I say, non-IT background. If I say, if you guys face any kind of any issues, do stop me. I'll try to keep it as high level as possible, as kind of generic as possible. Okay. And for the students here, I would particularly take 10 minutes of yours time apart from this session in the last phase, let's say, just to guide you up, like, what are the different pathways you can take up from here. So that is one of my favorite favorite, like, favorite, that should be one of my approach towards this session. Like, what are the different ways, and in the industry, in IT world, in corporate world, where you can go forward. Awesome. So hi all of you. Kenneth, Joel, Lisa, Twins, Andrew. Okay, great. Thanks for joining, all of you. Thanks for joining.
Kazi, I think we shall start the session so that participants will keep us joining in the middle of session.
That's absolutely fine. Okay, we can start off. Fine. So, okay. So just a small introduction about myself, guys. I'll just switch on my camera if that helps. Okay, can you guys see me? Hey guys, can you guys see me? Anyone? Yep. Thanks, guys. So I'm Kazi. Yep. So just a brief introduction. I'm into this IT field, or let's say into this AI and IoT field, working for the last 6 to 7 years in this IT field for 9+ years. And I have founded multiple companies in terms of IoT and AI based applications right now. Apart from that, I am right now working as a product consultant and a product manager in one of the company called Hipla. You can see the logo up there in my video. So this is a company which is known as Hipla Technologies Pte. It's a Singapore headquartered company, and I'm working as a product manager in terms of the different kind of AI applications, which I'll discuss in a bit, basically. Okay. Apart from that, I'm involved in multiple communities and multiple student communities across the globe, namely GDG, that is Google Developers Group. I am involved in many of the sessions, and also in the core community of India. Apart from that, I am taking the session in terms of as an Intel Software Innovator today. So Intel has a very unique program where they take up the different kind of innovators all across the world and created this program called Intel Software Innovator. I'll also guide you up students, like for the students, how to become student ambassador for Intel, and for the innovators across the world, you also can apply for this Intel Software Innovator program and can get into this program. This is a very interesting program where we are taking up different kind of like hardwares which Intel comes up. We test it out before coming into the market, the different software stacks. Like one of the software stacks we are going to talk today is another product of Intel, which is an open source product, which is known as OpenVINO. So yeah, Apart from that, I'm very actively involved in different kind of hackathons all across the groups, and it's my favorite pastime. You can say every weekend there are different type of hackathons, and I would suggest the same for you guys. So yeah, this is my kind of a brief profile which I am working into. So you guys can, even after this session, can take my LinkedIn and we can connect over LinkedIn for any kind of questions and any kind of queries even after this one. I'm approachable via different mediums. LinkedIn is one of the best medium we can get forward basically. So this is my short intro. So today's session which we are going to take is like on a very interesting problem application that I'm working with Hepla. I'll try to take up the different components that I work and I'll try to decipher them into the different kind of technologies. Then I'll go into a bit into the different concepts of IoT, the different concepts of AI, and how what is OpenVINO and how this can help implementing your different kind of solutions. Hello, hello guys, can you hear me?
Yes, yes.
Did you hear the last 15 seconds?
No.
Sorry. So guys, yeah. Hi, just a bit small introduction about me. I am Kazi. Okay, so right now I am involved in multiple aspects. So I am in this field of IT for like say, my voice is breaking. Is it better now? That's okay, great. So yeah, again I'm Kazi. I'm like working in this field of IT and AI basically, specifically for the last 6 years. Okay, and into this field of IT for a decade close to around. I have founded multiple companies, took exits from some of the startups. So right now, currently, I am associated with a company called as Hipla Technologies PTE. So that's a company which is situated in Singapore, headquartered in Singapore, and has multiple offices in India and US. So I'm acting as a product consultant manager there. So I'll be discussing some of the applications that I am working in that company and break it up into different kind of technologies. As number one, apart from that, I am associated with multiple student and
Kazi, please unmute yourself.
sorry guys, someone is making me mute. Okay, great. So am I audible now?
Yes, you are audible.
Okay, great. So yeah, as I'm continuing, along with that, I'm working in HipLab. Along with that, I'm like associated with multiple communities across the world. Let's say in terms of GDG and in terms of Intel Software Innovator. So from Intel Software Innovator, I'll be taking the session today. This is a very interesting community where people from across the globe, let's say innovators, come across and test out the different kind of softwares that Intel would be coming up in the next year, basically on the next quarter, and the different kind of hardware they come up. For all the specific students today who have joined, I'll be sharing some links basically, which is an incentive for them. Like you can become Intel student ambassador from your respective countries and can be Intel globally reclaimed ambassador. Apart from that, all the professionals, I'll be giving you up links to become the Intel. The topic today I have chosen is futuristic building with IoT and computer vision. So yeah, I'm working in this company as a product manager at Hiplab. So where we are developing the different kind of technologies which helps us in order to make a building smart, make a building futuristic. The different workflow automation, for example, visiting an office and how to make it different kind of automated way in order to make it energy efficient, in order to make it very, very easy to use. And in during the time of COVID, the entire workplace automation have been changed. So people, industrial things have changed. So there has been a huge decline, as you all know. So how people would come back to offices, how people would come back to the industrial units. So there's kind of solutions which we are working about, and we would discuss amongst them. Okay. So yeah. So basically, just a second. Yeah. So I'm sure like most of you have heard the term called IoT. IoT is nothing but it's let's say Internet of Things, and now in future how it has been developed. So it has been coming on from the time of World War II, like the different kind of devices which are getting interconnected to each other. Like say, so for example, to make a device, a very very non-smart device, for example, your computer, or let's say your tube light, your bulb, your motor pumps, and everything. So if you get connected and if you can control it over the internet, it can become a smart device, right? So a very vague definition of a simple IoT device is like, say, every day data which can react to the different kind of impulse you send, or it can collect a different type of data. It can be called as a smart devices, right? So for example, if I go into a very formal definition of what is IoT, so just going before that, a formal definition of IoT, if you say there are in number of things which we are associated in today's life. Say for example, right now we are associated with the computers, with our home appliances, and if you are in office, you are associated with the different kinds of components in offices, right? Say for example, your home lights, say for example, your home ACs, or other different kind of applications. If you like, say for example, connect all these things with a network, so the basic backbone of this entire technology is we connect it with a central network. Through that network, if you can pass on the different kind of information, it's being called as an IoT. So for example, it's a bidirectional information from the network devices to your things. Now the normal things can like say pass on some information to the network. It becomes a smart device. So a formal definition would be a system of computing devices which have a unique ID. Obviously, say for example, to identify a unique ID, say there are n number of things. Amongst them, in order to identify a unique thing, you need to have a unique ID. We'll come to that, how to address them, how to allocate the different unique IDs. And once they become a unique ID and capable of transmitting data over the network, it gets connected to an Internet of Things network, and it becomes a smart device, right? Okay. Now say, what is a smart building? So the different kind of concepts which are coming up in today's world is a futuristic building or is a smart building, right? Say the first question comes into my mind, is my building or is your building smart in some way? So in today's world, in many of the offices which you go are trying to be smart, because that increases the economic value of the places, that increases the energy consumption of the places, that gives you in terms of the security implementation. Sorry. Now say for example, you have an office and you need to like secure the office in terms of the different kind of intrusion, right? Say for example, you have CCTVs, but the CCTVs do not have the capability to monitor the movement. So someone have to be kept in front of the CCTV screens, and he has to monitor, let's say, hundreds of screen, or many people have to monitor, and even then there might be some errors of judgment of humans, right? Say for example, now if you implement a different kind of computer vision algorithm, say whenever a person is coming through this door, let's say after 8 p.m., there should be an image of that person goes into the mobile of yours. And these kind of solutions are increasing the security aspects. For example, we work in different industrial units, and there are different kind of accidents which happen. Say for example, a person carrying a load and he gets and he falls down and he falls down, and that specific moment has to be reported to the manager. That can be done by the different computer vision algorithms. Okay. So these are the different kind of smart building, different kind of industrial innovations which are coming up. There are safety sensors which you all must be knowing, like there are carbon monoxide sensors, there are motion sensors, fire sensors, smoke sensors, which makes up a building smart. So these sensors are available, you just need to connect them over a network, and which connects them to a platform, and that moment it becomes a smart device or a smart building if you're connecting the different appliances. Okay. So yeah, sensors are everything's in the building. So it can improve the different kind of building energy efficiency and sustainability, reduce the maintenance cost with predictive maintenance, optimize the different space utilizations, enhance the different kind of tenant security, comfort, and safety. So there are different kind of use cases, and one of the like the essence of this session after this session would be you people living in your own area can come up with a small problem statement regarding these kind of the different kind of use cases that we are talking about, and you need to build up a small solutions in order to implement the different kind of understanding you had today, right? Okay, so let's say for example a very generic example, or a very let's say very easy installations or the easy use case example is the different kind of home automation technology which are coming up. So in home automation, in terms of lighting and HVAC control, can bring you a huge amount of consumption reduction in terms of the energy and the usage and the bills that you pay basically. So for example, in a room there are, let's say a system is there. Okay, if we go 30 people are there in the room, the AC, the air condition should go into 22 degrees, let's say. And let's say when the people count is getting to 10, the temperature of the room should go up to 24 and something like that. These all things can be automated, right, in terms of the different HVAC control via the different IoT concepts. Okay, switching off the different kind of colors, the different kind of RGB settings, and all those things can be done. The temperature control of your system, the automation of doors and windows. Obviously there are huge companies coming up, say for example, if you're not in your home and a package comes up, he can give you a call over the he can give you a video call from the door, and you can see like what is the package, and you can guide him, and you can let him enter or not. And there are different type of intrusion detection which are coming up in terms of the different IoT concepts. So basically in a very short nutshell, if we call it up, it's all about making our lives easier with all the stuffs at our fingertips, right? um, let's say it's all about making our lives easier and secure would be a good definition with all the different type of stuffs that we are handling in our day-to-day life. So that is all about the different kind of IoT and the different kind of use cases which you can go forward with it, right? So now to increase the efficiency in terms of the computer vision part, so there are different kind of face recognition algorithms which are coming up, which are enhancing the security system. And due to this recent COVID, the entire attendance system of the module, which happened via biometric before the days of COVID, has completely changed into face recognition based security system, right? So there are different kind of motion detection sensors which are available for intrusion alerts. There are different sound sensors for glass credit, and many more which you can configure according to the different kind of use cases. So these are very practical based implementations which happen across the globe in terms of smart in terms of converting a non-smart building into a smart building, right? So yeah, so if you just divide the different use cases according to the different kind of aspects in terms of ease of use, in terms of monitoring and safety, in terms of security actions control, yeah, you can find the different kind of sensors which are available for, let's say, monitoring and safety. There are carbon monoxide sensors, there are fire sensors, and many other kind of sensors which can be used for different types of use cases, right? And there are different kind of other sensors in terms of the security and access control, which can be done via sensors or which can be done also via computer vision enabled techniques, like say for example monitoring the feeds via an AI algorithm. Okay, so yeah guys, any queries till now, like if everything is going fine? Okay guys, anything, any queries till now? Okay, Shivani, you need to help me, because if I'm going back to the screen of my PPT, so I'm not able to view this one. So if anybody comes up with a question, you need to stop me and you need to like say, uh, notify me, right? Okay.
Sure, I will interrupt you if in case if in case there is any question.
Sure. Thanks. Okay, great. So yeah, I share my screen. Okay, guys. I assume that you are able to see my screen, right? So now the next question is very important question come up with so many technologies all around the different kind of sensors, all around the different kind of networking. We have learned from the last few slides. Let's say how do we combine it, right? Say there are different kind of sensors, there are different kinds of algorithms that we need to write, say for example. So on a very high level, there are two ways to basically combine them. Okay, so one is a decentralized system. So this is a very, very high level IoT architecture, which we generally follow in the industry. So there are different things which are available, or we say terminals, or we say node, let's say T1, T2, T3, T4, T5. Okay. So you obviously need a network connectivity in terms of how do you connect all these devices over the internet, let's say. If you are trying to control it from across the globe, you need to connect to a network. If you try to also you can create certain intra network within your home using your own router, and you can connect all these devices through your own network only. So any which way you need a network connectivity, right? And these network connectivity should touch upon a IoT platform, or we call it a cloud, or we call it as an application layer, right? Say, so all this information need a place to reside. All this information needs certain rules. So for example, if the temperature is 30 degrees centigrade, my AC should get switched off. All this information should be there. Should be a cloud platform which would be interacting with the network connectivity, which would be interacting with the terminal, different kind of terminals or the different things. Okay, so these are all different kind of decentralized system which we follow generally in terms of connecting the different kind of things which are across the globe, right? Say now, okay, I have a question for everyone right now. Say for example, what can be the other kind of a system, or what should be the alternative of this IoT architecture? This is one way this works. What do you think is a negative or the cons of this system? The pros of the system, we understand, say it gets connected to the network, and through one network we can control all the devices. So any guesses, like say what are the different cons for using this system, by going through this decentralized architecture? Anyone, guys? Anything would be okay, basically. Okay, you are seeing this architecture, right? So there are different things which are connected to one network, which are connected to a platform. Any cons which you feel can happen from this entire architecture or entire data flow, which we call? Okay, Hakwal, privacy issues. Can you go into a big detail? Say, let's say what where can be it should be, where can it get into privacy issues? Okay, I think guys can come up, unmute yourselves, and like you can come up with your questions. Okay, then we can go forward, because this is the way a session should happen, right? Because if I go forward with different kind of concepts, doesn't make any sense if you do not understand the concepts, right? I'll just go into concepts. I'm not going coding or anything like that. Okay, anything. So yeah, so Mr. Hakwal, yeah, you are quite correct. Say for example, the entire network connectivity for all these devices is this one network connectivity. So in any way, if I hack this system, if I hack this network, or in any way through this cloud platform, if I hack this network, I would be able to control all these devices, right, in my own way. And generally people who hack devices, they do not control in the way you want. So this is obviously a privacy issue. So either you have to make it the best of the privacy standards which are followed in the network connectivity, but there is always a concern. So if you connect one terminal, if you connect one network, there is always a privacy issue. Okay, any question, guys, apart from that? Okay, so guys have gone into centralized and decentralized. I'll discuss centralized, decentralized, then I'll discuss versus which one is better. So another approach is a centralized system. Okay, you guys are very smart. You have seen the next part of the slide. Okay, so for example, this was the decentralized system, right? Okay, so there are things which are available. There are things which you want to connect to a network, which gets itself connected to the IoT platform, right? Now, in between, if you create a local IoT gateway, or let's say call it as a gateway. So what would happen? Each of the thing would not be sending their data directly to the network connectivity or directly to the main router, this is also a gateway basically. So they would not be sending it to the main gateway. they would sending it via a local IoT gateway. Okay, in this way what happens is that it's a very, very strong system in terms of privacy. Even if this gets compromised, you have to again compromise this gateway also. So there's a double or a triple layer of security which happens. Okay, the other good points in a centralized system, which is a kind of complicated architecture in terms of decentralized system, is for example, okay, if there is no local gateway, it all sends this data to this one. If there is a down or some system gets down into this network, the entire system gets switched off, right? So if there's a local IoT gateway, at least the users can control it via within his own intra-network. That is one thing which we can go. The system doesn't go down completely. Okay. The other thing is that there are other issues as well. Say, for example, this entire network connectivity is being routed through a server or is being routed through a very special, a very powerful router. So if there is no local IoT gateway, you need to have very, very powerful router or a very, very large storage service if your devices are sending huge amount of data. That can be again done away with a local gateway, because there is another architecture also. Say T1 and T2 is connected to local IoT gateway 1. See, T3 and T4 connected to local IoT gateway 2, T5 is connected to local gateway 3, and in this way they are all getting connected to one network connectivity. That is another architecture which we can follow in a centralized system. Now, this is another way of designing the architecture. Now, to come to your question, one of the participants asked, like, which is a better way, right? So one is a decentralized, the other is a centralized system. Honestly, the answer should be according to the use cases. For all the students right now, I do take a lot of interviews for different companies, including Intel, including other startups and globalized companies. This is a question we do always ask. So to answer this type of question, don't jump into saying that, yeah, this is better, that is better. It always depends on the use case that you are doing. Say, for example, I'll give you a very, very particular use case. Okay, I'll just jump back to okay, just a second. Sorry guys, yeah, so just to give you an example, let's say, can you see me guys? Okay, just understand a concept. Say, for example, you are monitoring the traffic signal of your area. Okay, and you are trying to detect the speed of each vehicle passing through four corners of a road. Imagine in each corner there are 4 cameras. So in 4 corners there are 16 cameras, right? So one is a decentralized architecture of sending the data. From the 16 cameras, you are connected to a central router or a central server, which is connected to an IoT platform. Okay, all the 16 cameras sending that to that central server or the router or the main network gateway, basically. Okay, you need a very, very strong gateway, because each one of them is sending huge amount of data. Huge amount is so video frames are nothing but pictures in frames, right? In sequential frames, it goes in certain frame speeds, right? So it's sending the data. Don't you think there would have been a better way? Say each 4 of the cameras is sending into a local gateway, and each gateway 1, 2, 3, 4 gateway is connected to the main router, and that is sending to let's say the IoT cloud platform. Won't that be a better way? Yep. Okay, rather than sending it directly to a decentralized way. In these type of use cases, obviously the answer is centralized way. Now, for example, you are trying to automate your home, basically. Okay, your home, there are 4 devices, and 4 devices can be directly connected to the internet to offer your router, and that can directly send the data to the cloud platform. So in terms of cost wise, in terms of feasibility wise, there is no requirement of coming up with a new gateway, right? So that increases the cost, that increases the, let's say, in terms of data transfer speed also, right? That is the second. Okay. Okay. Does a charging laptop at 100% would affect the battery life of laptop? I'm not the right person for this question, but I'm sorry. You would have to ask some hardware experts in terms of.
Because you are charging at present, you are charging the laptop. That's why I've asked the question.
Okay, I do not want to take a risk of going away. My laptop battery is not doing that well in terms of its health. Okay, so that's the reason. Okay, yeah. So yeah, that's the basic difference between centralized and a decentralized architecture. Each one has have its own pros and cons basically. Okay, now going back to this one. So now obviously the networking communication, the network, this network connectivity can happen via two ways. There are other ways also will come up. There is a Wi-Fi connectivity, there is a cellular connectivity obviously available. Okay, there are different kind of protocols. Now these are the connectivity and these are the protocols through which they connect. There is low range, okay, low range LoRaWAN, low range wide area network connectivity, LoRaWAN connectivity. There's Sigfox protocols. So what is a protocol? Protocol is basically the set of rules how the data should transfer via Wi-Fi, or how the data should transfer via different mediums, such as let's say Bluetooth, such as let's say cellular network, and such as different kind of things. So BLE is another network connectivity in between short communications. So these four protocols are generally used for network connectivity between short gateways. Say for example, in a centralized structure, from your things to the local IoT gateway, these four communications can be used. The main communication from your local from your network connectivity to your IoT platform can be via the Wi-Fi and the cellular network. Okay. Is this fine, guys? Now, the different kind of cellular IoT protocols are, let's say, 2G, 3G, 4G, 5G is coming up very soon. Okay, it has already started its implementation in many places across the globe, and in India, it's also coming up. There are specific IoT-based cellular communication which have been provided by multiple companies, which are known as, let's say, NB-IoT, and which are LTE networks, right? NB-IoT is narrowband IoT network, where the specific providers of the cellular communications are giving you a bandwidth or a channel where the different communication would happen only of IoT-based data. So this is being activated by Vodafone in India right now, and I do not know like any other company across the globe are doing or not. Okay, great. Okay, so till this part is clear, guys? Any queries, anything coming up in your mind? Okay, any queries, guys? Should we go forward? Okay. So now let's say go into the computer vision part of this. So the last part which we were discussing all about the different kind of IoT base. IoT is basically transferring your data from the different things using the different. Now the things. Now say for example, your tube light is a non-smart thing, right? How can you make it smart? You connect it over a sensors. So these sensors along with your devices become your thing, and you obviously need a processing power, and these processing power devices send those data. So these are all IoT based concepts which we discussed in the last few slides basically. Now coming back to the computer vision part of the different kind of systems which we can use, say for example the facial recognition system, which can be used for the different security system, which can be used for attendance system. Okay, coming back to the different kind of applications which we are discussing in terms of the computer visions, right? So these are the different use cases which we can use. So there are different kind of systems which are coming up, which can always detect if there are empty vacant spaces in terms of parking, and there are other kind of use cases which we'll discuss. Okay. Okay. Now, this is a very important module in terms of automating the different office spaces. Okay. So there is a huge cost which goes in for the different visiting management system that the office has to maintain in order to visit a person coming from his gate to the office, right? Say for example, if this entire system is being used, so there's a car coming up, you extract the number from the registration plate. There are different license plate recognition ways which are available in terms of the AI-based algorithm. That happens on the edge. Now, what is edge? Edge is nothing but it's a local gateway. Okay. Then it's the local gateway sends it to the main network gateway, and it sends a notification to the owner with the registration number and the guest details to the owner. Let's say now the owner can open the, let's say, boom barrier gate or the main gate of the office, and the owner accepts or rejects. So this entire process can happen automatically with the use of the different computer vision based applications, rather than keeping, let's say, personnel for it, or having different kind of other traditional systems which are going across the world, right? So this is one thing. Apart from that, obviously there are other modules which are also available. Let's say booking a room for a meeting. So the user can go and enter his details. The details goes into the system, and it checks whether each of the room are available. Whichever room is available, the light gets automatically switched on. The AC gets switched on. The user uses the room. The moment his time ends, the light gets switched off. and all those where the different kind of energy management system can also be done, right? Say the other important aspects in terms of building safety and predictive management are, is say for example, whenever there are certain climatic conditions or something which affects the building in many ways, so we do not do proper ensuring. So say let's say periodic maintenance staff comes up and see, but they might miss a lot of things. So with the different building management system which are integrated with the different sensors in the water system and the electrical system, you can get the data real time and you can check, let's say, okay, yeah, this system is not working correctly, and you can also predictively maintenance this system needs a, let's say, recheck or needs a maintenance schedule or something like that. So these are the different other applications which can be again done. A very interesting use case I can declare, say for example, the different pipelines which comes across the different countries. It is very hard to manage because they come across continents and they comes across beneath the different oceans, right? So how do you manage the entire pipeline leakage system which sends across? So there are different drones which are carrying cameras and doing the different kind of sections of the pipes are being checked if there is any leakage or not. So this is another good example of a predictive maintenance which is happening. So yeah, now if we come to the different kind of frameworks that we can use or the data flow, say for example, we have different electric sensors to measure the current and the voltage. Okay, so this is basically nothing but a smart meter where you can see your electric consumption right now, how much you are using. Okay, and there are different water monitoring sensors, for example, testing the pH of the for testing the turbidity, for other parameters. Okay, and let's say there are also computer vision solution enabled. There are smart recognition for attendance of the employees, for license plate recognitions of the different car coming up. All these are sending the different data into a local IoT gateway. This is important, and this gateway can be as small as a Raspberry Pi. Whoever have worked with some IoT based hardware based devices must be knowing a Raspberry Pi, depending on the use cases, or it can go up to Intel NUC devices which have, let's say, 32 GB RAM or something, and let's say 4 core CPUs basically. So this local IoT gateway depends on the type of data which are coming up from the different networks, right? This local gateway sends it to a main cloud connectivity. This cloud can be anything. The most like the prevalent cloud providers are AWS that we generally use, that is the Amazon Web Services. There's Google Cloud Platform which are available, and there are other cloud platforms which are available where you can where it stores the data, where the different rules can be implemented and all those things. This can be all accessed by a user portal in the form of a web or in the form of a mobile application. So this is a very high level data flow, how a smart house framework is being designed whenever you design. Okay, is this part clear, guys? Okay, guys, didn't you follow my screen basically for the last 5 minutes? Really sorry. Okay, awesome. So this is the smart house framework I was trying to explain. So these are the different electrical sensors, which are current sensors, and they are sending all the data to the local IoT gateway. There are different water monitoring sensors, which are available again on the different use cases. There are computer vision smart sensors available for LPR, for attendance in an office space, and all these are coming to a local IoT gateway. Then it is getting connected to a cloud connectivity, which can be AWS, which can be GCP, Google Cloud, which can be any other cloud service providers. And they are here the different rules, the storing of the cloud, and the transferring of the data between two networks are happening, and which are to be accessed by a user portal in terms of a web application or in terms of a mobile application. Okay, is this absolutely clear, guys? This is a very high level way of how to design a smart house framework is being applied in the industry today. Then we go into deep of each one of them, which sensor which we use, which is the local gateway, which sensor would have a small processing power, that can be an Arduino, that can be a Node MCU, and all those concepts comes up, right? So but this is a very high level data flow architecture that we follow. Okay, is this part clear, guys? Any queries? Okay, so now how does AI helps us in analyzing these data? So obviously using computer vision, you can get a huge amount of data analytics. Say for example, how many people are coming at what time, And in terms of retail, there are huge amount of data analytics are being driven out, right? Say, like each people walking into Walmart, and what are they taking, their behavioral analytics and the different kind of predictions. The moment you scroll through Facebook, the point you click and everything is being taken up by the different data analytics. So say for example, whatever we are doing, if we can analyze that data, we could come up with very, very good productive outcomes. Say for example, how much you are using your electricity and how much it is wasting. All these things come up if you have a data analytics platform, or if you have this entire data and you perform data analysis. Predictive maintenance is one of the most important aspects in industrial units. Say for example, there are huge machineries going on. A machinery going down for 1 hour can cause a huge business loss. These can be avoided by the different kind of techniques which we have discussed. Okay. Right now my screen is not visible. Hello, is my screen visible, guys?
Yes, your screen is visible.
Okay. So when it comes to computer vision, cloud processing isn't a good idea. Any idea why? Guys, anyone can come up with a guess? So there is a statement: when it comes to computer vision based analytics, cloud level processing isn't a good idea. Why? Anything? Hello. Okay, first is time consuming. Okay, that's kind of correct. Yeah, partially correct, because obviously there would be a latency whenever you are sending the data to the cloud, and the cloud is taking real-time actions and sending back the data. That is one thing. Internet reliability is always required. Yeah, obviously. Apart from that, any other thing? Have you guys used cloud-based applications, anything in your let's say in your career right now, or like in your work? Okay, what can be the problem basically? These two are correct. So internet reliability always required. Security is another aspect. Yeah, because you are again following a decentralized architecture. If it gets compromised in between these 2 points, obviously there would be issues. The most important thing, if you would have used, you would have known basically. Any other thing? Yeah, think from a prospective viewer of an employee or a corporate. Basically, you are working in a let's say Intel is making a product. Yeah, the most important thing is cost. Yeah, because whenever we use applications and deploy application in real time, it's a cost factor, because yeah, cost and performance is one of the most important factor. Yeah, so basically if you send all the data, all the cloud data, all the computer vision data, you can do that. That's absolutely fine. But if you send, let's say you are trying to detect whenever a car is coming, you should extract the number of the car and send it to the owner. That is the kind of application which you are working. Now, say for an example, when it comes to computer vision, you are sending the frames from morning to evening to the cloud, and all the processing is happening in the cloud. So think from the perspective how much storage you are taking of the cloud, how much bandwidth you are consuming. Both are very, very costly. Okay, cloud storage is very costly, and processing is happening all the time. In between that, if you would have kept a local IoT gateway or a local gateway where there is a processing, say if there is a car, then only send that frame to the cloud. Wouldn't it have been better? So those frames which have car, send that data to the cloud, and cloud will extract the number and send whatever other operations it had to do. Okay, so we do the core level of processing at the edge level. Edge is basically the local level or the local gateway level, and then send the required metadata to the cloud. It saves a lot of bandwidth. It's, first of all, it saves a lot of cost, cloud cost. It makes the process a lot less complicated, because if you send all the data to the cloud, you would have to write logics in the cloud in order to do all the processing. So this is the main advantage of doing some AI analysis on edge than sending it to the data. Obviously, there are again debates, like say we can send all the data. Yeah, obviously you can, but again, depending on the use cases, you can take a decision. Okay. Yeah, there are cyber attacks which happens basically. Okay, so you need to employ the best of the standard protocols in between the networks. So that is the reason centralized architecture is much more preferred in terms of shielding towards centralized cyber attack, basically. Okay, now there are different, how do we do all these things, the different kind of computer vision enablement or the computer vision algorithm. So there are different frameworks which are available for doing it at the edge. Now why do we emphasizing on the fact edge? Because see, when you are going into cloud, cloud has multiple facilities for you. Cloud has CPUs of, let's say, 8 core and 40 GB rams, which because in order to, you guys would understand, in order to analyze the different frames of a videos, it requires huge processing power because it's huge amount of data, right? So in order to do it at edge, you have to optimize the frameworks, you have to write optimize algorithms, because you cannot keep a 40 GB RAM local gateway and say that this is my local gateway and then I'll set to the cloud, because that totally like defeats the purpose of cost management, because then you would have taken a 40 GB machine at the cloud. Why would you take a local gateway? So there are different, you have to, let's say, run this over a simple device such as Raspberry Pi, which has a 4 GB or a 8 GB RAM, and you have to run this entire application partially you can do it at the edge, and partially then you can transfer it over to the cloud, basically. So thereby comes different types of libraries or different types of frameworks which helps you doing the different process of computer vision based video analysis. Okay, OpenCV is one of the world's most popular open source library for analyzing the different feeds and the videos. OpenVINO Toolkit is another open source Intel distribution of open source framework which is used for deploying. What is OpenCV and all those things? OpenVINO, I'll come to it. Is this part clear, guys? Okay, I can share the PPT. That's absolutely fine. I'll share you certain links. I'll share you everything. Don't worry. Okay. Now, what is OpenVINO? Okay. Any idea till now? Okay. How many of you have ever worked on an AI model? Anyone have worked in an AI model? What is a model in AI? Guys, come up with anything. Hello. Can you guys hear me? Hello. Anyone have worked with AI here? No one? Okay, Shivani Gupta. Yes. You guys understand by the concept called model? What do you mean by model? Okay, I'll tell in a very generic way that makes sense. So basically, if you are training to identify a person, let's say, or identify a human being, what we do is we take huge amount of human images and send to the computer and write some program. It trains over that program and makes the program identify if any certain feature of this type of object comes up, this is a human and this is not an orange. Okay, then what do we do with that program? We make a model of that program and we apply it into the different kind of use cases. Okay, how does the Intel distribution of OpenVINO Toolkit differ from the open source version? So basically it's the same. Intel distribution of Open Toolkit is an open source version, basically. Okay, so OpenVINO has been okay, so for example, Python is there is Intel optimized Python, which have certain features which makes the different threading processes faster and other processes faster. Same way, OpenVINO is an Intel distribution of OpenVINO Toolkit, which is taken from the open source version only. Did I answer your question, perhaps? Okay, now what is OpenVINO? Okay, so there are some resources which are available. I'll share this. Shivani, if I can share these links with you, would you be able to share with them, or I'll share it in the
If you can share it with me, then even I share it with them. But I suggest you can directly share it with them in the chat section.
Okay, I'll do that. So yeah, so I'll paste some links. So these links are very important, very easy to understand, first of all. So you guys can take it even after this session. So I'll just give you a very small overview. OpenVINO is nothing but it's a small toolkit for deploying the different kind of models. For example, you have created a model and you are deploying it over the program. Now what happens, say for example, if you have created a model for detecting the license plate, now you are trying to run it over Raspberry Pi. It would give you some lag because Raspberry Pi is not that kind of a huge processing power, and it might cause you delay in that. OpenVINO comes into action in that it helps you faster processing of the deployment of the model. So it is not a toolkit for making models, but it is a toolkit for deployment of models. Understand the difference between them, guys. Did you get that? Those who have used certain aspects of models in their like application building, they would understand. So this is a very easy to understand kind of a flow diagram which they have given. So for example, what is the first step you do? You determine the different environments. Say for example, you want to run it over OpenCV, or you want to run it on any other environment basically. Okay, you determine the type of framework and you find a trainer model. So there are multiple models which are available in the whole world, like say open source model, TensorFlow, Caffe, MXNet, and all those things. So there are different kind of AI based models which are available. Either you take one of the models or you train your own model. Okay. Now, is the model is accurate enough? Very good. You can go into OpenVINO. If the model is not accurate, what would you do? You would again train it with a, let's say, newer data set. You will again train it with a larger data set, and you will do the other stuffs which are required to make the model accurate, right? Now your model is accurate. Your model is giving, let's say, in test scenarios, 99% accuracy. What do? You use the OpenVINO toolkit. OpenVINO toolkit comes in between creation of a model and the deployment of a model. It adds an extra custom layer of model optimizer. You don't have to do anything. You just implement the OpenVINO and it adds certain framework to it. It makes the model much faster. It makes the model much more optimized to use it at low processing edge devices. Okay. So now you run the model optimizer which are available. Okay. How to do that? We'll discuss this. Okay. Now, did the model convert rightly? No. So there are certain errors. You have to work on fixing that using some custom layers, using changing some parameters, H params or something like that. Those who have used it regularly, you guys would understand. Did that work? Very good. No. Then escalate to Intel or try alternative methods. Then it is not supported by OpenVINO. They are very clear about it. Fine. If that works, run the different kind of inference engine on models. So inference engine is nothing but a, let's say, it changes your this model into an intermediary code which is known as intermediate representation. Okay, so was it fast enough to accept acceptable accuracy? Now this model and this model has a change. Very good, you integrate a model to your application. Okay, no, then try it again, tuning it over the other different kind of models or the IR models which are available. If that is also not working, try hardware based intervention. You change the hardware, you make it a much a better hardware, or the different type of training extensions which are available, you try with that. Okay, if that works, run it packet. So it's basically an extra custom layer for data scientists or for the different models. Okay, to make the model run much faster. Okay, which is open source, which is you can get. Okay, there are different ways you can go forward. I would suggest you go through these links. Okay, there are different other links also. Okay, yeah. Sorry, how to install them? Okay, there are for different types of environment in your computer. For Windows, for Mac, you can directly install it on Raspberry Pis, that is using the Raspbian OS. For Linux and other mechanisms. Okay, so those who understand like what difference does it make, say for example, okay, I'll show one more thing, then I'll go back to this one. So just to have a, this is a cheat sheet which I will share again with you all. So for example, okay, there are different, like we showed in the last one, like there are different kind of train model which are available: TensorFlow, Caffe, CalD, MXNet, and all those things. You take up a model or utilize your own pre-trained model. Okay, run the model optimizer of OpenVINO toolkit, converts and optimize it using a supported framework. It runs it and converts into an intermediate representation of an XML file. You put it in the inference engine, and there are different kinds of processing powers, like say available: Intel Xeon, Intel Atom high processing, and other kind of hardwares. So this intermediary XML file or bin file can be directly run over these different kind of hardwares or these different kind of architecture. You do not have to write different types of architecture for different type of hardware according to their processing power. Okay, this is the main utilization of OpenVINO basically. Okay, guys, I tried to make it as generic, as high level as possible. Is this fine, guys? Okay, so you can see this GitHub is available again, open source Intel GitHub is available. I'll share it first and discuss. Okay, so these are the different kind of models which are available for integration with OpenVINO. Almost all the utilizable models of the world are available. Okay, and there are accuracy percentage which increase, and what are the accuracies which are coming up using the implementation of OpenVINO are all being recorded up here. Okay, all the codes are available. You can always try. This is a very informative and a very good GitHub repo to use basically over your application building. Okay, so yeah, this one also I'll share. So this has all the kind of performance benchmark, how to do it, and all those things. We will have a, let's say, another session planned with Shivani, and then we can again take this up in the next level basically. Okay, the last part of the session, I would just encourage one to see this. So I was talking about cloud. So cloud is costly, and AWS do give us some free and everything. There is also a cloud provider in terms of Intel Dev Cloud, which has all the machines of the edge. Intel Core CPUs are available inside this. You can go, it gives you access for almost 2 months of free access using this one. Okay, so you can go and you can register. If you guys face any issues, you can tell me. I'll talk to Intel and give you the access for free. This is a very good cloud platform where you can host your different kind of applications for different kind of application building. Okay, the last part, okay, time is very short, but I'll just tell you, I'm working on this application which is known as ContactTrack.ai in Hipla. This is an application which has been developed by our team basically. So you can see this is an application for contact tracking management and breach distance. I'll show you this one. Okay, so this is a real-time implementation which is going across in India in one of their offices in an industrial unit in Gurgaon. Okay, you can see like this employee has breached with this employee at a distance of 5.9 feet. This is being done through mobile using their Bluetooth sensors, and computer vision also this has been done. And you can see, let's say one of the guests has, okay, so these 2 person have breached. Whenever there is a breach occurs, uh, it tracks them, and it stores the snap basically for the people. And this application has been widely used all over the country using multiple by LG, by Bosch, and other companies also. This is one application which I'm working. The other applications which I work basically, if you can see, let's say yeah. So this person is not walking through this line, so she is unsafe. She should not walk between them. Whenever there is an unsafe uh, whenever this person goes beyond this line, a notification goes to the manager. This all happens basically. So yeah, these are the different kind of applications we are working. Okay, sorry, can you hear me? Okay, for the speed detection of vehicles. Okay, yeah, so yeah, thank you guys, thank you. If you have any questions, you can please.
Dear participants, we are open for discussion and for questions. So please go ahead with your questions.
Okay, my laptop model is Legend 540. Okay, it's very fast actually. It has a RAM of 32 GB. So thank you guys. Thank you for joining. We will have continuous session if this session makes some sense to you. I do understand that many of you are not from AI background or something like that. So I would be able to help you out more accurately. I'll talk to Shivani, and we can have some sessions which are very specific to your requirement. We can also do that. But yeah, so regarding the certificate questions, Shivani can handle it. Okay, apart from that, any other queries from the session? I would suggest to have a look through that OpenVINO model, and I would suggest all of you take the advantage of this Intel Dev Cloud. The link I've shared, it's a 2-month free Dev Cloud, and do you guys know Jupyter Notebook? Anyone have used Jupyter Notebook? If anyone have used Jupyter Notebook, DevCloud directly supports Notebook. It's like working in a notebook only. So it's a very, very cool feature to have, basically. You guys can work on it. Okay?
Yes. I guess for the feedback section, I just share you the feedback link, Kazi. You can go through it and you can get an idea about the feedback from the participants.
Sure. So do let me know also if after all the feedbacks have been submitted to you. Okay?
Sure.
If there is
Sure.
anything we can help, uh, I'd be happy. So yeah, just a last one, if this makes sense, I'll share my LinkedIn profile. You guys can get in touch with me over LinkedIn.
You can rather share your email ID. So if in case any participants have any query, he or she can directly approach you through the email or through your LinkedIn profile.
Okay, sure. So my email ID I'll put up in chat. Okay. So this is my office ID. Okay. Oh yeah. One very important Shivani surprise for all of the participants who joined. For the students, basically, my company is looking for good number of engineers in terms of computer vision and in terms of full stack development. If anybody of you are interested, you have seen the different kind of applications that you are working on. So feel free to approach me. Feel free to send your CVs for internships and job opportunities, basically. Okay. If that's fine with you all, then
Kasi,
LinkedIn.
please share your LinkedIn ID too.
Okay. As LinkedIn is the most preferred medium for communication for me. Yeah, you guys can always approach me.
Right.
Thanks, Kyle. Thank you all for joining. So Shivani, can I leave? That's fine for
Yeah,
today.
you can leave.
Oh,
Meanwhile, I just fill up the feedback form from the participant side.
sure. Thank you. Thanks,
Thank
Mr.
you.
Paul. Thanks for joining. Thank you, Shivani, for
Thank
the
you.
opportunity. Bye bye.
Thank you. Bye.